Today we are going to discuss regarding balancing redox reactions. There are two methods to balance these redox reactions, and I'm going to discuss both methods today with some examples. I will guide you through all the steps that you need to complete to get the reaction balanced. And this is a very important topic in your exam because you will get to do chemical calculation questions involving these balanced redox reactions. Before start the methods, I will give you some overview regarding what is oxidation and what is reduction. In the reaction, you can see zinc converts to zinc 2 plus, right? And you can see copper 2 plus converts to copper metal. Let's take zinc converting to zinc 2 plus. Zinc, the oxidation number is 0. Then you can see zinc 2 plus, the oxidation number is plus 2, right? And you can understand when converting zinc into zinc 2 plus, it is losing 2 electrons. That's why zinc has the plus 2 charge. In the same way, you can think about copper 2 plus also. After taking 2 electrons, copper 2 plus ion becomes copper metal, right? So then you can see in these two half reactions I took, one reaction is losing electrons and the other one is gaining those electrons, right? That's why the mnemonic comes oil rig. They says oxidation is losing electrons and reduction is gaining electrons. And you can say the same thing using oxidation numbers also. You can understand here zinc oxidation number is increased now and copper oxidation number is decreased, right? So you can say increasing oxidation number is oxidation, decreasing oxidation number is reduction. So you can easily understand the 2 electrons that are lost by zinc is gained by copper. Right. I will teach you the first method. Here you can see the steps that you need to follow to get the reaction balanced. And I took some example reaction also. First, we are going to discuss this half-ionic method. Okay. So in this method, what we are doing is we break the two oxidation half and reduction half and we balance them separately. Then finally we combine them. And there is another method that we do without separating the oxidation and reduction half. So I'm going to discuss that part in the last part of our video. Right, now let's start from here. You can see the reaction is IO3 minus reacts with HSO4 minus to give you I minus and SO4 2 minus. You can see the first instruction. Write the reaction and find oxidation numbers. You can check the oxidation number of IO3 minus. It is coming as plus 5. HSO3 minus, you have to check the oxidation number of sulfur. It will be coming as plus 4. And I minus, oxidation number will be minus 1. SO42 minus, oxidation number will be plus 6. Now I will remind you how to get these oxidation numbers. Just for this example, just for reminding that step, I am doing it, okay? And try to understand that part here. So let's take IO3 minus. We need to find the oxidation number of iodine. So that is the unknown oxidation number. So let's take it as X. Normally, you know oxygen's oxidation number is most of the time minus 2, right? Then we can say, by doing simple calculation, sum of the oxidation number should be equal to the charge of that particular ion. So here we can say now x plus minus 2 into 3 equals to minus 1, right? And then if you simplify this, x minus 6 equals to minus 1. You can understand now how it is coming plus 5, right? So then I will do it for HSO3 minus also. Now, like I said, sulfur is the unknown atom here. Oxygen normally has minus 2 oxidation and hydrogen normally has plus 1 oxidation, right? Then You can do the calculation. X plus 1 plus minus 2 into 3 equals to the charge. Here charge is minus 1. Then you can understand x plus 1 minus 6 equal minus 1. X minus 5 equals minus 1, and then finally x will be equal to plus 4. So it's very simple, right? You use mathematical method and find the oxidation number. Remember, always the sum of oxidation numbers are equal to the charge of that. By that method, we can find oxidation numbers. So that step is done. Then what is the second step? Here you have to check the oxidation numbers and separate half equations. Half equations means oxidation half and reduction half. Now you can understand, as we earlier said also, increasing of oxidation number is oxidation. Decreasing of oxidation number is reduction. So now here, oxidation number of IO3 minus has decreased to plus 5 to plus minus 1. Oxidation number of HSO3 minus, the plus 4, has increased to plus 6. That means this one should be the oxidation half. HSO3 minus goes to SO4 2 minus. Then reduction should be the other one. IO3 minus should be decreased to I minus. Right, like that. Now you understood the oxidation and reduction halves. Then you can go to the next step. The next one is you have to identify the redox element. What is redox element? Redox element means the one that subjected to oxidation and reduction. Now you can see here in this one, you have three elements now: hydrogen, sulfur, and oxygen. So in which element oxidation number changed? So if you check oxidation numbers, hydrogen plus 1, but here in this side you don't have even hydrogen. Don't bother about that one. Let's take oxygen. It is minus 2 here. Here also it is minus 2 because it is its oxidation number normally not changing. But if you consider sulfur, the oxidation number is changing from plus 4 to plus 6. That means our redox element of this oxidation half is sulfur. Then our redox element of the reduction half, you can understand, it must be iodine. And then what is the instruction says exactly? After identifying them, you must balance the atoms. Right? That means if you had two sulfur atoms here, you have to put 2 in front of this, but you don't have like that. No? You have only one sulfur, one sulfur. So it's already balanced. You don't need to follow that step. Okay, so then you can continue to the next step. Like that, Lamai. The third step is not always coming to the balancing. Sometimes, like situations here, we have to skip that step. So the next example I am taking, I'm going to teach you how to use that step also. Right? And then let's consider the fourth step. Now you have to consider the change of oxidation numbers and add electrons. Now the oxidation number was here plus 4 and plus 6. So now the change of oxidation number is by 2. Right? The oxidation number which was there at plus 4 has increased to plus 6. You have to consider that change and add electrons. So within bracket you can see I have given, if it is oxidation, it loses electrons. So that number of lost electrons you have to add to the right side. Right? Now you can see here it is 2 electrons are lost. So let's add that 2 electrons to your right side like this. Let's try it for IO3 minus also. So the oxidation numbers are changing from plus 5 to minus 1. Now what's the change? From plus 5 to minus 1, the change is 6 electrons. Right? 6 electrons. Now think about number line. Right? In your number line, plus 5 is somewhere here, and 0 is somewhere here, and minus 1 is somewhere here. Now the total change will be 6 electrons. Okay? Don't confuse with the positive and negative numbers here. You have to consider that properly. Okay? Then what is the change of electrons? As I said, 6 electrons. Now it is gaining electrons. No? So then you have to add that electrons to the left side. Now we consider the oxidation number change. Then we can go to the next step. Balance charges. Right? Balance charges. And you can see there, if it is acidic medium, you have to use H plus ions. If it is basic, or if they didn't mention the medium, that means neutral, you need to use OH minus. Right? But I highlighted here H plus because I'm giving this reaction for you to balance in the acidic medium. That means to balance the charges here, I have to add H plus. Now, what is this charge thing? They are referring here, Lamai, the charge of the right side of the reaction and the left side of the reaction. Explain you more regarding that. Now, what is the charge here? It is -1 because you have only -1 charge. But when you consider the charge of the right side, not only the anion, you have to consider the charge coming from electrons also. That means the charge will be -4, right? -4. Then to balance that charge, you need to add hydrogen. Let's add hydrogen to both sides and see what will happen. Then you can understand it properly. What if I add hydrogen to left side, right? Then what will happen? Your charge will get increased, no? That means it will become 0 and it will become +1, +2, like that it will increase. But it will never equal to -4. That means, Lamai, for balancing charges, you need to add that one to the more negative side. Isn't it? Then you can increase that charge to become equal to the other side. Now, think about that. If you want to increase the charge from -4 to -1, you have to add 3 H plus ions. So you have to do it for the right side. Okay, then if you check the overall charge, you can understand both the sides will become -1 charge. Now let's try it for the IO3 minus reduction equation. Here the overall charge will be -7. Here charge will be -1. Then to balance that charge, you can understand you have to add 6H plus to the left side. Okay, then if you check the charge, both sides will become -1 charge. In that way, you can balance the charges of oxidation half and reduction half. What is the next step they are telling? The number of hydrogen ions, H plus ions you added. You have to balance that one by adding water. How many hydrogen atoms are there in this side? You have 3. In this side, you have 1. So then you need to add 2 more hydrogen to this side. You can do that one using water. You can add 1 water molecule to this side. Then to confirm whether we did the reaction correctly, we can check the oxygen atoms. Right? Now, if you check here, you have 1 oxygen, you have 3 oxygen. Only together you have 4 oxygen atoms. If you consider this side also, you have that 4. Right? If it is coming equally in the last step, that means we have done our balancing properly. Right? Now let's complete it for IO3 minus side also. Now you can see 6H plus I added to this side newly. Then I need to add 3 water molecules to the right side. Now again we can check for the oxygen atoms. Here you have 3 and here you have 3. That means that side is also correct. Right? In that way you can balance the oxidation half and reduction half here. Right? But to get the final reaction, you need to do one more step. Let's look at that. First of all, I am labeling the 2 steps. Let's label this as 1. Let's label this as 2. Now, let me remind you one more thing. Earlier, you saw during oxidation and reduction reactions, in redox reaction, the number of electrons that are gained by reduction reaction should be released by the oxidation reaction, isn't it? Total electron exchange should be the same. But you can see in these two halves, IO3 minus needs 6 electrons, right? But HSO3 minus only releasing 2 electrons. So it's not enough now. That means you need to multiply the first equation by 3, no? Then it will release 6 electrons. That 6 electrons can be taken by IO3 minus. Considering that, you can get the balanced ionic equation using both these reactions, right? That means I need to multiply the first one by 3. Then electrons will be cancelled. Now you already know that. No? You no need to write electrons when you are adding the reactions because we adding them in a way them to be cancelled. Then I can put 3 water, 3 HSO3 minus. Then I'm considering the left side of this reaction. Right? I don't have to change anything here. Just have to add 6H plus IO3 minus. Then I'm considering the right side of this reaction. You multiply that one by 3. So for 2 minus into 3, right? And here 9H. Then I can add the right side of the other. I minus and 3 water. Now you can see water and H plus are coming in both sides. You have to simply cut them. Simply. Now here you have 3 water molecules and here you have 3 water molecules. And here you have 6H plus. Here you have 9. So that means 3 will remain. Then you can get the final reaction. 3HSO3 minus and IO3 minus goes to 3SO4 2 minus and I minus plus 3H plus. Then how this is becoming important in our chemical calculations? You need to get this ratio, 3:1 ratio. We call it as stoichiometric ratio, right? That means with 1 IO3 minus, you need 3 HSO3 minus to react. You can put it into moles also. That means 1 IO3 minus moles will react with 3 HSO3 minus moles. Like that. In chemical calculations, you have to use those ratios and do the question. Okay, and this is how you balance this reaction completely. And later, I will teach you how to balance the same reaction using oxidation numbers without writing several steps like this. Okay, Lamai. Now let's try to balance this reaction is also in acidic medium, right? This is our second example for acidic medium, right? So as they instructed in the first step, we need to write the reaction and find their oxidation numbers. Now I assume you are familiar with finding oxidation numbers. Okay, now the oxidation numbers of these entities will be, here nitrogen will have plus 3 oxidation state. Here you have 2 chromium atoms, but if you use the mathematical method, you will get the oxidation number of 1. And I will show you how you are getting that one. Cr2O7 2 minus, no. So then if you take this one as x, now there are 2 chromium atoms. So 2x plus minus 7 into 2 is equal to minus 2 charge. 2x minus 14 equal minus 2. Then 2x will be equal to plus 12 and x will be equal to plus 6. So don't worry about that one, Lama. Just take the oxidation number of one atom here. Oxidation number equal to the charge of this one, 3, and here it is plus 5. Now you can see oxidation number has increased in HNO2. It is from increasing from plus 3 to plus 5. This will be our oxidation R. And your redox element will be nitrogen, right? Chromium oxidation number is decreasing from plus 6 to plus 3. And our redox element is going to be chromium. Here's the third step. For this balancing lamai, third step is important. You remember earlier balancing, we didn't need the third step because atoms were same. But now you can see here you have chromium 2 atoms. But here you have, in our starting reaction, you have only 1 chromium. So that means here the third step is applicable. Before going further, we need to balance this, right? So then let's try it for the chromium's reaction. So that means here you have Cr2O7 2 minus, no? Then you have to put Cr3 plus. In front of Cr3 plus, please apply Do we need to do that step for the HNO2 reaction? Okay. Because it's already one atom is there. So then we can write as it is. Right. Then we can go to the next step to consider oxidation number change. Now in HNO2, oxidation number increased from +3 to +5. That means oxidation number increased by losing 2 electrons. So we write 2e minus in the right side. And if you consider dichromate, you have to do this thing before you go any further. Okay, let me show you that. Now we consider here only one atom. Now we, after balancing atoms, you can see the atoms are increased by 1. That means we should do the same change for the oxidation number also. Right? Now you had 2 atoms, therefore I need to multiply this one by 2 and get the total oxidation numbers, means plus 12. Here you had 2 atoms, so multiply this one also by 2 and get the total oxidation numbers as plus 6. Now you consider the change of oxidation numbers from plus 12 to plus 6. Okay? Not plus 6 to plus 3. You consider it from plus 12 to plus 6. Then, what is the change of oxidation numbers? If you consider the whole thing, it has taken 6 electrons. Then you can continue 5th and 6th and the other steps as usual we did in the earlier balancing, very similar. Now this is the tricky part, doing the 3rd and 4th steps. Those are very important for this balancing. Let me continue them quickly. Now the charge will be here, -3. Here the charge is 0. Then I have to add 3H plus to this side. And if you consider dichromate reaction, if you check the charges here, it's going to be -8, right? And here it is +6. There are 2 chromium ions. Then if you want to equal the 2 charges in this both sides, you have to increase the -8 until it becomes +6. You have to add 14H plus. 8 is given for cancel the -8 charges and another 6 is there to increase the charge up to +6. Consider the number line. That's my advisory. Then you can freely balance the number of hydrogen you added by adding some water. Now let me consider the total overall hydrogen atoms in both sides. Here you have 3 and here you have just 1. So then you need 2 more hydrogen. Then here you have to add 1 water molecule. And in this side, now you have 14H plus in the left side and there are no any hydrogen other than that. So that means you have to add 7 water. So that's it. Then if you check the oxygen atoms, here you have 3 of them, here you have 3, here you have 7, here you have 7. So that means our half reactions are okay, they are balanced properly. Then let's try the other step also that I instructed. So if you consider the whole process, you can get balanced ionic reaction. That means the total number of electrons that are lost by oxidation half should be gained by reduction. Now, like earlier one, here also it needs 6 electrons, but this one is losing only 2 electrons. That means we need to multiply our oxidation half by 3 and then add it to the second one. 3 water, 3 HNO3, sorry, HNO2. Then I write the other one, 14H plus. You don't have to change the reaction of reduction reaction. Okay. Write it as it is. Then we move to the right side of the reaction, 3NO3 minus, 9H plus, then 2Cr3 plus, and 7 water. Right. Then you can cut water. Here you have 3, 7 here, and 4 will remain. Here you have 9, but you have 14 here, so 5 will remain. So then finally you will have 3HNO2, 5H plus, Cr2O72 minus, then 3NO3 minus, 2Cr3 plus, and 4 water. Just to make sure, let's check oxygen one more time. Here you have 6, and here you have 7, so altogether 13. In this side, you have 3 into 3, 9, 9 plus 4, 13. That means our reaction is correct. Okay, now I am going to do this balancing for basic medium, right? Basic medium. So in acidic medium, we applied H plus for balancing charge, but in the basic medium, we are applying OH minus for balancing the charge. As instructed in the first step, we are writing the reaction and we need to identify oxidation numbers. Here plus 7. Here if you consider one carbon atom, will be plus 3, plus 4, and plus 4, right? Then oxidation half will be C2O4 2 minus goes to CO2, and your redox element is carbon. Here reduction half will be MnO4 minus reducing to MnO2, and your redox element is manganese, right? And then you need to balance atoms like we did earlier. You can understand now there are 2 carbon atoms, so then I need to put 2 in front of carbon dioxide, and here you don't need to do anything. Then lamai, in the next step we are considering the oxidation numbers and add electrons. Now this is oxidation numbers will be plus 3 and plus 4 to 1 atom, right? But we are considering 2 of them here, so you need to multiply it by 2. Overall you have plus 6, and here you have plus 8. So from plus 6 to plus 8, oxidation number is increased, right? That means you have to add 2 electrons in this side. And let's do it the same for the other one. So oxidation number decreased by gaining 3 electrons. Then now it is basic medium. Let's check the charges first of all. But there is a important thing here. Here your overall charge is minus 2. Here also your overall charge is minus 2. So it's already balanced. No need of adding any OH minus or anything. Right? So then you can simply cancel this one. It's already balanced. We have to worry about the reduction half only. It will have minus 4 charge. Here you have 0 charge. Then now you are having something negative to balance the charges. Now, if you add OH minus here, then negative charge will get increased. Therefore, don't do it. You have to add OH minus to your right side and change the 0 charge, decrease the 0 charge into minus 4. Let's add 4 OH minus ions. Finally, we have to balance hydrogen. We introduced 4 hydrogen atoms newly. So then it should come to your left side as 2 water. Then to make sure whether we did this correct, please check oxygen atoms. Here you have 2 and 4, altogether 6. Here you have 2 and 4, 6. We did it correct. Then, like we followed earlier, Lamai, you want to multiply the reactions and add. So I will label this as second one. This is as the first one. Now oxidation half losing only 2 electrons, but reduction half needs 3 electrons. So in this kind of a situation, you have to get the least common multiple. Right? You multiply the first equation by 3 and then add it to the second equation multiplied by 2. So let's do it and see. 3 C2O42 minus 2 MnO4 minus 4 water go to 6 carbon dioxide, 2 MnO2 and 8 OH minus. This is the balanced ionic equation. No need to cut any hydrogen or OH minus or water. Here it is coming like this. Right? So your ratio is 3:2. It's basic medium. It is very simple. Just like acidic medium, you have to follow all the steps only in one step. In the fifth step, you have to add OH minus instead of H plus. You can understand like this also. If it is acidic medium for these reactions, you are adding H plus to the opposite side that you are adding OH minus, isn't it? If you do this reaction in acidic medium, you will be adding H plus to this side. But now, we add OH minus to the other side. And just remember, we are doing it for balancing charges. Now let's do one more question using basic medium. Now this question I took specially because it's a very important balancing, right? Very commonly asked in our exam also. Aluminium reacts with nitrate ions to form ammonia gas, right? So this is a test for identifying existence of nitrate ions in aqueous medium. That's why it is asking so many times. You will learn this stuff in your sixth lesson. For now, don't worry about that one. Just focus on balancing this one properly. So now it is happening in basic medium. Let's try our same steps on this. First of all, let's get the oxidation numbers 0, +5, +3, and -3. Now, oxidation is aluminium goes to AlO2 minus. See that redox element is aluminium. Reduction is NO3 minus decreasing its oxidation number into -3 by forming ammonia. Redox element is nitrogen. You can see their atoms are already balanced, so no need to follow the third step. Then let's go and check change of oxidation numbers. Aluminium oxidation number increased from 0 to +3 by losing 3 electrons. NO3 minus has decreased its oxidation number from +5 to -3 by gaining how many electrons? From +5 to 0, 5 electrons. 0 to -3, another 3 electrons. So then it has taken altogether 8 electrons. Isn't it? Then let's check charges. Here if you check the charge, it is 0. Here it is -4. Then to balance charges, you have to add 4OH minus to your left side. Okay. And if you check the charges here, it's -9. To balance that one, here it is 0. To balance that one, you have to add 9OH minus to this side. Right? Then let's add water to balance hydrogen. Then here you have 4 hydrogen, right? So then there are no hydrogen in any other place, right? And then to balance that one, you have to add 2 water molecules to your right side, 2H. Here, Lamai, the thing is, you have 3 hydrogen here and you have 9 hydrogen here. You have to consider all hydrogen atoms. You have altogether 12 hydrogen. That means you have to add 6 water molecules, right? Then let's finally check your oxygen atoms. Here you have 4. Here you have 2 and 2, 4. Here you have 6, 3, 9. Here you have 9. So then our oxidation and reduction halves are correct. Last step. After labeling them, reduction half need 8 electrons, but oxidizing half losing only 3 electrons. So we have to get the least common multiple. That means we need to multiply the first equation by 8 and then add it to the second one multiplied by 3. You will have some bigger numbers and you will see something interesting at the end also. It's great. Now you can cut this OH minus and water. Water and OH minus are remaining at the same side. Now earlier balancing, most of the balancing, you are getting them to different sides, right? And here it is to the same side. So then your ratio is 8:3 ratio. That means to react with 8 aluminium, you need 3 NO3 minus. Okay, so that's it. Then Lamai, by these examples, we consider how to balance these reactions using half-ionic method. So we broke the reaction into two parts and then we balance them separately and finally we join them. That is our half-ionic method. And you have two examples for acidic medium and two examples for basic medium. I took them in a way that we can cover all the theory areas and all the special points that we need to know regarding this method. Now I am going to teach you the next method. It is going to be somewhat interesting for you because we don't need to write all these things in that method. Okay. So we are going to balance the same reactions that we balance in our half-ionic method. And you can see I didn't mention any steps here because you need to understand and do it because you have some practice from our earlier method. Right? Please refer that one and get fully understanding of the topic. Right? Then you can easily do this. That's why, Lama, we are teaching the half-ionic method first. Then we go for the oxidation number change method. Okay, so this is how we are going to do it. Listen carefully. First of all, we write the reaction and we find the oxidation numbers. Now the oxidation numbers are, here it is +5, +4, right? And -1, +6. These same things we saw earlier how to find, and you can check it again, just to remind, right? And then what you need to do, Lamai, if there are atoms to be balanced, you do it. Okay, and here there are no atoms to balance now. I mean, iodine you have one, here you have one. Sulfur you have one, and here you have another one sulfur. So no need to bother about that step. Then you mark these oxidation and reduction by separate arrows. Now IO3 minus decrease the oxidation number, while this one increase its oxidation number. So this is reduction and this is oxidation. And then consider the change of oxidation numbers. Now IO3 minus reduced by gaining 6 electrons. I'm writing +6E. And HSO3 minus oxidized by losing, you can understand by checking oxidation numbers, by losing 2 electrons. I put it as -2. Then, now you have to understand the theory of redox. Okay, in oxidation, some electrons are lost. That same electrons are accepted by reduction. In other words, you can say if some electrons are needed for reduction, that same electrons must be released during oxidation. That means here IO3 minus needs 6 electrons, right? But HSO3 minus losing only 2 electrons. So that means you need to 3 times like this. You need 3 times like this in electrons. Then it is enough for IO3 minus to reduce. Then if you multiply this oxidation by 3, you need to do the same for their entities also. Like this. So you see, it's like this you do. Then here we already cancel the electrons, right? And there will be no half equations. There will be no cutting electrons. Right? So we already did it in this system. Then the other steps that we need to follow here are same like our half-ionic method. What you need to do is simply, we'll be taking another color. You have to check the charges in this side. Here the charge will be here -3, -1, -4. And this side charge will be -1 and 3 times -2 is 7, -7. Right? And then to balance charges, since it is in acidic medium, you are adding H plus. You have to add 3H plus to this one. Then both sides will become equal to -4. Okay. And then to balance hydrogen, we need to add water. So here you have 3 hydrogen and here you have 3 hydrogen. So no need to add water actually, because here you have the same hydrogen atoms in both sides. That's why Lama, okay? We must not add water, right? It's not a must thing. If it is necessary, we add water. That's all. Okay. Now I hope you understand how to balance this one. So it's very simple, right? Now if you do this method in exam, you will get full marks. Like you are getting in your half-ionic method. So in that one, it may divide marks into oxidation half 5 marks, reduction half 5 marks, and full equation 5 marks, like that 15. Here you will get those all 15 marks here. Okay, so then my advice is practice this method more often in your exam. But before doing this one, you should have a clear understanding of half-ionic method because basics theories are mentioned there. Now let's do our second acidic medium balancing also using the same method. I wrote the reaction and let's find the oxidation numbers. Here it is plus 3. We are considering about one atom. So therefore plus 6 will come, plus 3 will come, and plus 5. Now we need to balance atoms. Okay. Here you have 2 atoms. So therefore I must put 2 in front of this. Then we need to change the oxidation numbers to be adjusted for 2 atoms. Now here you have 2 chromium atoms. Therefore, you have plus 12 oxidation state, right? And then here you have 2 of them. So here also you have plus 6. Now let's put those arrows. It is oxidation. Here it is reduction. Now you can understand during oxidation, it lost 2 electrons. So you can say it like minus 2e, right? And during reduction, if you consider the whole oxidation number change, it has taken 6 electrons, right? Taken 6 electrons. So then to balance the electrons, like we did in earlier example, we need to multiply our oxidation half by 3. So that means 3HNO3 and 3NO3 minus. Then like we did earlier, we must check charges. Here, the overall charge will be minus 2. Here, your overall charge will be 2 into 3 plus 6 and minus 3 plus 3 will be the overall charge. Okay. Then to balance that one in acidic medium, you have to add how many H plus ions. To cancel minus 2, 2 H plus ions, and to make it equal to plus 3, another 3 H plus ions. So altogether you have to add 5 H plus ions this side. And then by considering all hydrogen, here you have 3, and here you have 5, there are 8 hydrogen, then you must add 4 water molecules to next side. Then to make sure we did the reaction correct, balancing correct, let's check the oxygen atoms. Here you have 6 atoms, here you have 7 atoms. So 13 oxygen atoms are there. Here you have 9, here you have 4, again 13 oxygen atoms are there. So then we did it correct. Now let's try balancing basic medium reactions also using our method. First of all, let's find oxidation numbers. Plus 7, plus 3 for one atom, plus 4, and plus 4. Then we need to balance atoms. Here you have to put 2 carbon dioxide, right? Then adjust the oxidation numbers, 3 into 2. And then overall you have plus 6. Here into 2, overall you have plus 8. Check the oxidation number changes. Here it is oxidation. Here it is reduction. Then electrons, during oxidation, it has lost 2 electrons, Lama. During reduction, it has gained 3 electrons. Okay, then you need to multiply the two sides separately, right? You need to multiply this one by 3, this one by 2. So then 2, 2, 3, and then here I need to erase this number. Because I need to multiply this one by 3. So then it will become 6. 2 into 3, 6. You have to follow the usual steps. Check the charges, both sides. Here, the overall charge will be minus 2 into 3 minus 6 plus another minus 2 will be minus 8. And this side, there is no charge. So then you need, this is basic medium. Then we need to equal the charges here by adding OH minus. So then let's add 8 OH minus ions here. Then both sides will become minus 8 minus 8. Here there's no other place that is having hydrogen. We have to add 4 water here. That's it, very simple, isn't it? Now we can check oxygen atoms before we go any further. Here 4 and here 2 into 4, 8, 12 and 3 into 4, 12. Altogether 24 oxygen atoms are there. Let's check the other side. 2 into 2, 4. 6 into 2, 12, 16 and another 8, 24. So in both sides you have 24, 24 oxygen atoms. Our balancing must be correct. The last one. Then if you check the oxidation numbers, 0, plus 5, plus 3, and minus 3. No need to balance atoms. Then let's directly consider the oxidation number change. It is increasing oxidation numbers. Here it is decreasing oxidation numbers. Here it takes, during reduction, 8 electrons. Here it is losing during oxidation 3. So then we need to multiply this side by 8 and this side by 3 in order to equalize electrons. Right? And we have to do the same thing for their entities also. 8, 8, 3, 3. Then we have to check about their charges. Here am I. In this side, you have minus 3 charge. Here in this side, you have minus 8 charge. So then to balance charges, we have OH minus in our hand. We have to add 5 OH minus to this side. Right? Then both sides will become minus 8 minus. Then before adding water, consider all the hydrogen atoms. Okay? In this side, you have 9 hydrogen atoms. In this side, by now you have 5. Okay. Then for balancing, you have to add water to the same side. Isn't it? For more hydrogen, then that should be added as 2 water molecules to this side. Then your reaction will be balanced, and it is somewhat important because you get water and OH minus to the same side. Okay, let's consider the number of oxygen atoms. Here you have 2, here you have 5, 7, and 3 into 3, 9, 16 oxygen atoms are there. And in here you have, in the right side, you have another 16 oxygen atoms. So then it's balanced. So like that, Lamai, that is how you balance redox reaction. So I hope you had a complete idea regarding the lesson. If you have any doubts, you can always ask me. Then I have something for you also to do as a homework. In our tute, I have put these redox reactions. You have to balance them in acidic medium. You can try them and send for corrections. And these are to be balanced in the basic medium. Right? You can do any of this reaction, basically any given thing in your exams using one of these two methods. Okay. What I recommend is the second method. But before doing the second method, you have to have enough practice, enough questions you have to do from half-ionic method. Then you can come to this method and do balancing very fast. Okay, because the basic theories of this method are discussed in the earlier method. And that's how you balance your redox reactions. Right? And then thank you and have a good day, Rahman.